Right, can you guys see that okay?
Yeah.
Okay. All right, so let's do a couple things with limits involving infinity. Okay. First of all, when we're talking about limits that involve infinity, what that really means is that we're talking about a vertical asymptote if we're talking about the graph approaching infinity or negative infinity. And last year I did have you guys describe behavior around an asymptote. So let's just take a look, and why don't you go ahead and you can even put this on your graphing calculator. If I gave you the function f of x equals 3 over x minus 2, or I guess we don't need to have our graphing calculator out. Can somebody just tell me what that's going to look like? And what? And it's the rational function, or not? Yeah, no, yeah, we call it the rational function. So it's like a hyperbola here and here. All right. So if we're doing things graphically, and I wanted you to describe the behavior at this asymptote, we would describe it from the left and the right. So how we could write that is this: the limit as x approaches 2 from the right. Okay, so with my finger I'm going to just show that. The function's going up, right? Towards infinity. Now, as far as the technical definition of a limit, different books will approach this in a different way. Some will say that you need to tell me that there really is not a limit, but the function tends to go towards infinity. It doesn't seem like the AP board seems to care if you write it this way, as long as you understand infinity just as describing what the function is doing. It's really not a number it's approaching, but I think you guys do. What if I wrote this? As x approaches 2 from the left, what's the function doing? The function is going towards negative infinity. So this is one way where we are talking about limits involving infinity. You guys some of you knew what the graph looked like. Another way that we could do this would be numerically. So let's just do a table. Second. And we know that the function is undefined at 2. So I'm going to put 2 in the middle. And let's start getting closer to the function. So maybe we would make this 1.999 and 1.99 and 1.9. Do you guys remember doing this at the beginning of the chapter? Okay. And over here we could do like 2.001, 2.01, 2.1. Okay. First of all, we know that this is undefined, right? Put that there. Okay. I already have my table set up for ask. So I'm going to put some of these things in. Why is this not, it won't let me clear it out? Huh. Alright, well I'll just start typing things in. Hopefully you can see it. 1.9, the function is 0.99. Just double check that I have that incorrectly. I do. At 1.99, it's 0.999. No, something's wrong.
You know how the functions plug in.
Did I not? I don't know. Is this what you're getting to now? Can you not see it? It's, when I put 1.99 in, I get a negative 30, negative 300. 1.999 is negative 3,000. Okay. Can you guys see that these numbers are getting closer and closer to like a negative really large number? And that's this left-hand limit coming from the left. That's what that means. Alright, so then coming in from the right, if I started typing in, okay, so we know it's undefined at 2.001. I don't know if you can see that any better. That at 3,000, 2.01 is, okay. Alright, so numerically, that's how I would address that. Okay, and then if I didn't have a calculator, you do need to try to think about if it's going to be approaching negative infinity or positive infinity. And here's how I would do that. If I would think about a number bigger than 2, wouldn't that make this whole thing be positive? So then I'm thinking, coming from the right, I know it's going to approach positive infinity because I'm talking about numbers that are larger than 2, which will make the whole thing positive. Coming from the left, if I have something that's less than negative 2, I'm going to have positive over negative. Does that make sense that it's going to be like negative numbers then? And that makes hopefully some sense that it's going to be negative infinity. Okay, now, let's take a look at another one. Do you guys know what, for instance, let's see what else they give in here. How about if I did this? I want you to think about what happens when I put numbers. First of all, we know there's an asymptote at 2, correct? But what does this adding that squared do to these numbers? Anybody want to take a guess? What's that? Jacob?
Making all the numbers in the bottom positive.
Yeah. So guess what? From the left and the right, because I'm squaring those numbers, it's going to make the behavior on the asymptote on both sides approach positive infinity. Take a look at the graph. Oops. Well, you can see around 2, can't you?
Yeah.
Okay. So do you see how from the left and the right around 2, they are both approaching positive infinity? So I'd write that limit as x approaches 2 from the right is infinity, limit as x approaches 2 from the left is positive infinity. Also, I think that we are aware, hopefully we are aware, that vertical asymptotes in general, how have I been finding these? What am I looking for? Vertical asymptotes occur where? When denominator equals 0, right? Do you guys need me to talk about that anymore? That's something we talked about in pre-calculus. We're good with that? Okay. But there are some other things that have asymptotes. Can you think of some other things that have asymptotes? Trig function, tangent, cotangent. So you should also be aware that those things and also don't secant and cosecant. Okay. Tangent and cotangent, tangent occur at odd multiples of pi halves, remembering that, okay? And so, in tangent, you should be able to evaluate tangent looks like this, okay? So, like if I'm talking about this asymptote at pi halves, from the left it's approaching infinity, from the right it's approaching negative infinity. You should be able to figure that out. Cotangent is at odd multiples of pi, or at, yes, like 0, no, just integer multiples of pi, I'm sorry. 0 pi, 2 pi, 3 pi, 4 pi. Did you guys remember on that sheet that I had you do? Refer to that for now. So same thing, and cotangent's going down, isn't it?
Yeah.
Okay, secant and cosecant, just make sure, again, those are the little u's. They have asymptotes in the same manner as tangent and cotangent, so that you guys can find vertical asymptotes for those things. Okay, let me see what else I need to talk about. I think that's it. We talked about removable, non-removable, right? Same thing, so Alexis, that ties in, not just you, I know you're not the only one who had that question. That ties into this conversation, because if you see this, something like this, no, I meant x squared minus 25. Which one is going to be a vertical asymptote then? X equals negative 5 will be a vertical asymptote. This will just be a hole in the graph, okay? And if you wanted to figure out what this limit is, we've done that before. We would cancel, right? And we would actually put in a 5. It would go to 1 over 10. But yeah, so knowing that if it's removable, that would just be a hole in the graph, not a vertical asymptote. Okay, so our code word.
We're gonna have it be price this week.
Okay. So we'll see how that works out. So if you're listening to this, maybe when you return to class, you can talk to me about if you saw this video or not.